All right, we now have the energy measurement chip installed, the Analog Devices ADE, what's the number again, 7763. We are reading the accumulated active energy register right now. The current on the test set is off, and you can see it's just creeping up. Okay, I'm going to put on 0.2 of an amp, turn on the current, and you can see the accumulated energy, the integration of watts, is rapidly climbing. This will of course have to be scaled to some real-world value. Obviously we don't want 0.2 of an amp at 120 volts to integrate that rapidly, but you know, this is a 24-bit register, and there is a divisor we can put in the firmware in the ADE7763 to cut down that speed. But this just gives you an example of integrated energy. Okay, I'm going to shut it off at this point. I just shut the current off, and now what I'm going to do is I'm going to pretend you use that much power, and now I'm going to take the phase angle on the SSR78 and turn it to 180 degrees to make power go the other way. Now I'm going to turn the switch on again, and you can see 33, 32, 31, the number is going down because I have power going in the opposite direction, and this is the equivalent of running the meter backwards. If you had a meter and you were putting out power into the system and the meter was capable of running backwards, this is what it would do. It would count down. As we see, the raw energy register here is counting down at this point. Okay. Okay, we've counted it down to almost zero, and now we'll take a little tour of what it looks like now. Widen up the view here. Okay, that you see a picture, that's the SSR78 relay test set I'm using as a source. It's set to put out 120 volts at 0 degrees and 0.2 amps at 0 degrees at this point. Here you see the circuit board we had before. Once again, there's the processor module, and now, in contrast to the other film, I've installed the clock oscillator and the energy measurement chip, as well as the calibration components for that circuit. Notice I have a couple of transformers over here, little toroidal transformers. That one of them I used for a potential transformer. The other one I run a wire through the middle and use it for a current transformer. It's very accurate. They're both very accurate for this application, as long as you keep them well below saturation. I even turned the test set down to 90 degrees and it barely moves, so there's very little phase error. And so of course the next part of the project will be to install the DC measurement for the solar panel DC output, and finish doing some better software for this so we can, you know, scale the watts to like 1 watt hour per count or something like that, along that line. And that's all we have today, folks.